All right, this is Math 1. This is your Unit 1A review. It's kind of the halfway point in the full Unit 1. And so we're going to work through some of the solutions that are part of the review worksheet that you received in class. So let's begin with number 2. Number 2 is a great one. It's also very similar to number 3 because they both start with a negative in front. Just recall that this means that you could, if you wanted to, put a 1 right there and think of this as being a negative 1 in front of what's in the parentheses. We're going to use the distributive property, and we're going to multiply that negative 1 throughout both terms that are inside of there. So negative 1 times a negative 12 becomes just a positive 12, and a negative 1 times a positive 5x becomes a negative 5x. So the way we simplify that is just like that. There's nothing else to do. Basically, we're just changing the numbers inside from negative to positive and positive from negative to negative. So 12 minus 5x there. On number 4, we're going to multiply 1/4 to the 12j and a 1/4 to the 28. So it would look something like this if you were to write it out. It could look like 1/4 times 12j minus 1/4 times 28. Alright? Writing it that way, I can think of this as almost like a little couple fractions, and I can reduce on the diagonals. 12 divided by 4 is 3. So that becomes 3j, and 28 divided by 4 is 7. And I keep the minus sign in front, so I have 3j minus 7. Looking over to number 5, rewrite the fraction as a sum or a difference. Just means we're not solving it, we're just rewriting it as a sum or a difference. If you recall from our lesson before, we're going to take these two terms that I can look at diagonally and put the 11 with the first term and the 11 with the second term. And so the way that looks, it looks like 9, oops, I put a G there, sorry about that. We're going to write down 9y over 11 minus 2 over 11. And now I have it written as a sum or a difference. I could also write this down as 9/11 y minus 2/11 if you don't want to keep the y up in the numerator. Either one works. Okay, that's why I wrote or there, just so you have an idea. Let's look at number 8. For number 8, we're going to first of all combine our like terms, okay, in order to write it as a sum or a difference. So I have an x, 5x, and I have a minus 3x. So let's combine those to begin. So 5 minus 3 is 2x. Next I see that I have a whole number. I have a minus 3, and I also have a positive 4. 4 minus 3 is just 1. And then I have remaining here this one term, the y term by itself, which is just a plain old plus 6y. So now I've rewritten it as 2x plus 1 plus 6y. On number 9, on this one over here, we're going to distribute first the 7, and then we're going to solve. So 7 times n is 7n. 7 times negative 3 is negative 21, and that equals negative 35. I will then add 21 to both sides here, and that goes away, and I'm left with 7n equals, well, I have 35 and 21. Our rule is when the signs are different, negative, positive, I find the difference and I keep the one with the bigger sign. So in this case, I will actually do 35 minus 21, that's the difference. And I end up with 35 minus 21 is 14, but the number that has the greatest absolute value is the negative one, so this stays a negative 14. From here, I'll divide both sides by 7, and so 7 over 7 is 1, so n is going to equal negative 14 divided by 7, a negative divided by a positive, still a negative, and 14 divided by 7 is 2. Our next one, number 11, same idea, except I have the n first, no problem, and then I have to distribute the 5. 5 times n is 5n, and 5 times negative 1 is negative 5, and that equals 7. Now let's combine like terms. I can group this up. 1n plus 5n is 6n, and I can add 5 to both sides. And so 6n would actually equal 7 plus 5 is 12. I'll divide both sides by 6, and n equals 2 for number 11. Moving down to number 14. Another good problem here. Very similar to what we did up in number 2. Again, there's that negative 1 in front, so we're going to distribute that throughout those two numbers in the parentheses here, and then rewrite this. So the rewriting would look like 2r, and instead of just minus 1, it becomes a minus 5, and negative 1 times negative r is positive r, equals 13 plus 2r. Alright, so we combine our terms here. R and 2r becomes 3r. I still have minus 5, equals 13 plus 2r. Now let's move things around so the variable's on one side only. Okay, so I'm going to subtract 2r here, subtract 2r there. That goes away, so 3r minus 2r is simply r. And let's add 5 here and add 5 there. That goes away, and 13 plus 5 is 18. And now I'm all done with number 14. I want to move down to the next one right below it, number 16 next. It's a great problem with the fractions on it. Just a little bit different in how we want to approach that there. So let's take a look here. I'm going to rewrite this one over here actually, give some space. So I'm going to rewrite it right over here as, I'm going to rewrite it this way, as 3/4 x minus 1/3 x equals 10. Now recall, I can multiply any number times 1 and it's still the same number that it was. And any number could be something like 2 over 2, and that is still equal to 1. Just like 3 over 3 is still equal to 1, and 4 over 4 is still equal to 1. So for this first one here, in order to combine my like terms, I need a common denominator. I have a 3 and a 4, so I can't work with those very well, can I? But to get a common denominator, I'm going to look and say, well, if I multiply the first one by 3 over 3, 3 times 4 is 12. And if I multiply the second one by 4 over 4, 4 times 3 is 12, I'm going to end up with a common denominator. But notice that 3 over 3 is really actually just 1, and 4 over 4 is also just 1. So I haven't changed anything, I'm just looking at it differently and changing the denominator by multiplying by 1. So let's rewrite this then. 3 times 3 is 9, and 3 times 4 is 12, so I have 9/12 minus 4 times 1 is 4, and 4 times 3 is 12, x equals 10. So now I've converted these two different fractions of different denominators into denominators with the same base, or the same denominator, so 12 and 12. Now I can just do some math and combine terms. I have 9/12 minus 4/12. 9 minus 4 is 5. The denominator stays the same, and I keep my x there, equals 10. The next step would be to get the x by itself. To do that, I multiply by the reciprocal on both sides of the equal sign. Multiply by the reciprocal. So 12 over 12 reduces to 1 over 1, 5 over 5 reduces to 1 over 1. So on the left side I just have x, but on the right side I have 10 times 12, which is 120 over 5. I don't want to stop there because 120 divided by 5 does work. 5 goes into 120, and so x would actually equal 24. So it's a little bit lengthy of a problem for number 16. That's what we're working on there. But it's very doable there. So it's a great problem. You'll have something similar when you look at number 17, but I'm going to have you do that on your own. Again, find that common denominator first, and then you can combine your like terms. One last one to look at today, and that's just number 20. It's just solving the formula for L. And again, the goal here is all they want you to do is just make L be there where the P is. So we're going to move things around. So first thing I would do is subtract 2w from both sides. So I end up with P minus 2w equals 2L. And I want the L by itself, so I'll divide the whole thing by 2. And I end up with P, right here, P minus 2w over 2 equals L. And that's all we have to do. Okay, hope that helps. It's about half the problems there. Good luck studying for your test, and hope you do a great job. Thanks.